Friends, let's find the relationship between Young's modulus and bulk modulus. So E stands for Young's modulus and K stands for bulk modulus. So to find the relationship between E and K, we are going to consider a square block. So this square block is subjected to uniform stresses in X, Y and Z direction. So the stress acting in the X direction, Y direction as well as in Z direction are equal, and that is equal to sigma V. So this is called as a volumetric stress. Okay. So this particular block is subjected to a constant volumetric stress along all directions, that is X, Y and Z direction. So due to application of these stresses, this block is going to deform. So there will be change in volume of this particular block. So if I say this particular cubical block is having volume V and it is subjected to uniform volumetric stress sigma V in all directions. So due to application of these stresses, it undergoes change in volume by delta V. Okay. So now if I say this is X direction, this is Y direction, friends, and this one is Z direction. So we can find out the strain along X, Y and Z direction by using generalized Hooke's law. So let's find out that. Therefore strain along X direction. So we have done this in generalized Hooke's law. Kindly go back and refer those videos. I have already explained how to find strain in particular direction by using generalized Hooke's law. That's very straightforward. So I can say strain along X direction is going to be, so in the X direction you will be having strain directly caused by this particular stress, that is sigma V by Young's modulus. Okay. So this is a direct effect due to this particular stress which is acting in the X direction. These two stresses which is acting in Y direction and Z direction will have negative effect on that. That is why it will be minus mu times stress in, this is let's say Y direction. So Y direction again sigma V divided by E, and again this Z direction will also play the negative role. So minus mu, again stress is sigma V by E. Okay. So this is the expression for strain in X direction. Similarly, you can also find out strain in Y direction and Z direction, friends. So let me list down the strain in Y and Z direction. That will be straightforward. So strain in the Y direction will directly depend on what? Stress in Y direction, that is sigma V by E, and the remaining 2 will be negative 1. So mu times, let's say this is X direction strain. Let's say this is due to stress in X direction, and next one is the stress in the Y direction, friends. Okay, here since we got all three direction stresses same, so everywhere sigma V is coming. Otherwise we would have written sigma X over here, sigma Y over here. Okay, and similarly if you write strain in Z direction, friends, the same expression going to come, because Z also we have same stress, volumetric stress. So we have sigma V by E. This is let's say effect of X direction stress, and let's say this is effect of Y direction stress. Okay, so like that we will get expression. Please remember, this is the stress in X direction, this is the stress in Y direction, and this is the stress in Z direction. Okay, so since we have taken the hydrostatic stress system, so all three directional stresses are going to be same. Otherwise we would have different stresses acting in different directions. Okay, these are three strains we got in X, Y and Z direction. Now we know that the volumetric strain is nothing but summation of all these three strains. Okay, so if you add strain in X direction, strain in Y direction and strain in Z direction, you will be getting the volumetric strain. So that we can directly write down, friends. Therefore volumetric strain is given as strain in volume, that is equal to strain in X direction plus strain in Y direction plus strain in Z direction. Straightforward. So I'll write down here volumetric strain equals, now I'm going to add all these three together. Okay, you'll be getting sigma V, sigma V, sigma V by E. So it is going to be 3 times sigma V by E, and here you'll have these quantities are same. So 1, 2, 3, 1, 2, 3. So there are 6 times. So minus 6 mu times sigma V by E. Straightforward, no confusion, right? So I've simply added all these terms together. So I got the volumetric strain equals 3 sigma V by E minus 6 mu sigma V by E. So you can take 3 sigma V by E common, and the remaining will be 1 minus 2 mu. So now by Hooke's law, friends, we know that this is the volumetric strain. So we know that the volumetric strain is nothing but the volumetric stress divided by bulk modulus. Okay, since uniformly same stress is acting throughout, so this stress is going to be the volumetric stress. Okay, because all direction we are getting same kind of stress. Okay, so volumetric strain is nothing but the volumetric stress divided by bulk modulus. This is by Hooke's law, friends. This is from Hooke's law, that is stress is proportional to strain. We have already learned that. So by using Hooke's law, we know that volumetric strain is nothing but the volumetric stress divided by bulk modulus. So I can put that value over here in order to get the relationship. So I'll be getting like this: volumetric stress divided by bulk modulus equals 3 times volumetric stress by Young's modulus 1 minus 2 mu. Since this is the same stress acting throughout, so I can cancel it out. So this E will go here and K will go here. So from here you will be getting a very nice expression of E, that is E equals Young's modulus equals 3 times bulk modulus 1 minus 2 mu. So friends, this is the relationship between Young's modulus and bulk modulus. So we got E equals 3K 1 minus 2 mu. So this way we can easily find out the relationship between Young's modulus and bulk modulus. So this is the relation between Young's modulus, that is E, and bulk modulus, that is K. Okay.